Hello everyone. In this video, we will learn how to use online EasyEDA tool. Online EasyEDA tool is an alternative to CAD. So, in order to use this tool, we'll have to go to its website. Okay. So please go to the website, go to online editor. We may require to create an account. I had already created one. So the website will ask you to enter your credentials, your email, and your password to create one account. After you will create an account, then you will have to go to EasyEDA Designer. Okay. So once we'll start the online EasyEDA Designer, then we will have to create a project, or we'll create a new project or a new file. Say, for example, let us assume that we'll name this project as test07. You can name with any other name you want. So the moment we'll create a project, a worksheet will be present in front of us. Now uh, we will have to first make a schematic in this worksheet. So in order to make a schematic for any circuit that we want, we have to place symbols. Okay. Please note that there are two different types of symbols which are present in EasyEDA tool in this tool. One is the native symbols that are present in EasyEDA. Maybe sometimes the native symbols may not be present here. In that case, the symbols will be present in the library. Okay. Uh, or in this EE library, EE-lib file. Okay. So we can drag these components. For example, if we want to place uh, a ground here, we can place the ground or a resistor or whatever we want. So I'll go through the symbol editor. Uh, I will choose, please note, we have to choose LSG Electronics because this is a kind of online repository and we will have many components there. Suppose I want to place a resistor here. Okay. So we will choose the resistors if they are somewhere. There's a lot of combination here. You have connectors, we have amplifiers, analog ICs, and diodes. Everything is available in this library. So this library is just like you have many components or symbols available here, which are from standard vendors from the market. So we can choose anyone, whatever is suitable to us. For example, I want to use a resistor here. So let me use one resistor. So the resistor that I want to use, it is a through hole resistor. Okay. So I will be having here many available options that I could place on my schematic. For example, this is one resistor. If I would like to check what kind of resistor this is, there's an image that will show me the preview also. This is another one. This is a third one. Suppose I want to place this resistor. Okay. So this is a resistor that I want to place. So I will go for place, and by this fashion, this will be placed on my schematic. Okay. Now, suppose I have to drag a diode also. I have to include a diode also here. So I'll go for diode somewhere in place symbol. Then again into LCSC Electronics library, and I have to find now a diode. Okay. So diodes. Say for example, I want to place a light emitting diode. A light emitting diode will be probably present here in optocouplers and LEDs. Okay, so you have already many categories here. You can browse a suitable component from a particular category, whichever suits to you. Now I want to place a light emitting diode. A light emitting diode probably is present here. Okay. Now see which type of light emitting diode I want. I do not want surface mount device. Say for example I want a through hole type. Okay, through hole type. So there might be somewhere a through hole type device here, which I can select. So this is through hole type. So I will apply filters, and I will be able to find many through hole type of diodes. There is a mounting type. What kind of mounting I require? A through hole, or let us see what is available here. Or let us clear this second filter here. I will see the top view. I will apply filters, and many diodes will be available now. Okay. Suppose I want to place this diode. This is a suitable one for me. So I'll go for place, then I'll place this diode on my schematic. Okay. I also want a power source. I also want a power source, a battery. I can place the battery from here. If I will click on the battery, and I can place it on my schematic. If I want to rotate this component or the symbol, there is a rotate option here, rotate right. So it will be rotated. Then you can choose a suitable alignment for your component. Then there's a time comes now that I have to arrange these symbols in the form of circuit. So I have to complete the wiring pattern of the circuit. Okay, so it is time to make the circuit now. So choose the wire option. Here you have a wiring tool somewhere here. You can choose wire option, and you can then connect all these components suitably. You can tie them together to form a suitable circuit. Okay, so this is my circuit now. All right, now I want to create a three-dimensional CAD drawing for it. Please note, the moment I am placing them from the library, okay, the moment I am placing them, I have to choose from the library which component I am using. We can see it's three-dimensional view here. How this electronic component looks like. For example, I'm using a light emitting diode, or I'm using a LED segment display. So it looks like this. So I have to make sure that I'm choosing a right type of component in library only. Okay. So because once we will choose a component here, a footprint will be automatically assigned to that component. It will be automatically assigned to the component. So I have arranged the circuit. Please note that there is no requirement to assign the footprint to these symbols now, because the footprint is already assigned. Footprint is already assigned, and what type of footprint has been assigned to these symbols? It is visible from the library. Okay, place, symbol, and library. So I'm placing here, I'm choosing the symbols. So there is a default 3D footprint, or a footprint has been assigned to them by default. I cannot change them. If I have to change the footprint, then I have to change a different component here. I have to change a different symbol here from this search engine. Okay. So please note that I'm not using search engine EasyEDA, but I am using a search engine. I'm trying to look the CAD drawing or the components from LCSC Electronics. LCSC Electronics is a kind of online repository where you have updated electronic components available, which are actually probably present in the market. Then they provide you in the library that this kind of component is present, and its number is something like this footprint. Or you have an optocoupler which comes from certain company, maybe Vishay Intertech, and its number is DCLT 1009, something like that. Okay, so I don't have to it doesn't require an extra effort of footprinting like we used to do in KiCad. All right. So I can the summary of this discussion is, now I can create a three-dimensional view of this entire circuit very quickly. So I'll go for design. Okay. So design. First of all, I will have to save it. So I have to save it. save the design, whatever changes you have done, whatever wiring you have connected, then convert schematic to PCB. Convert schematic to PCB. Now you can see that you have many components here. Okay, this is probably the battery. You can drag all those components. This magenta outline of a rectangle, it will mark the size of your PCB. So your PCB is of this size. All the components, they should come inside this box. If you want to increase the size of PCB, we can do that. The size of the PCB can be changed, but let us keep the size, whatever is given there, that is the sufficient size for our PCB. So all the components, they are to be arranged inside this magenta box. So I will drag all these components. If I feel that they do not have a suitable placement, I need to rotate them. Then I can rotate them in order to avoid an overlap of the wire. Then I have a third component now as a resistor. I am also dragging that. Okay, and let us keep all those components safely within the boundary, within the border, magenta border, within this rectangular box. I repeat that this rectangular box, it marks us the size of the PCB that will be created. Okay, now I have kept all these symbols inside the PCB outline. Then it is a time to route them, to track them, or to connect, to draw the PCB tracks. So PCB tracks option, you have to go to PCB tools, then select track option, track, and then click from the source and go up to the destination. Similarly, from this side, we have to click here, and then I can move very easily up to the source point. So in this way, I will be able to complete all the tracks of my PCB. Okay, now I have completed the tracks on my PCB. I can directly choose a 3D option here. Go to 3D view. It will automatically create a 3D CAD view of my PCB, okay, or of my circuit. Please remember, I had an LED there. I also had a resistor, and I had a battery. Now the battery here is, it seems that the footprint of the battery here, it is a button, it is suitable for a button type cell. Say for example, I do not want this type of footprint for my battery. I want a 2-pin connector for my battery, so that I can connect a battery from outside and provide a power supply to my board. I can change it. I will have to close the 3D view. I also have to close PCB, okay, and I will not save it. Now, see, I have to change the battery. Please remember that the schematic here, or the symbol in the schematic that we are choosing here in EasyEDA tool, we have to select that symbol very, very suitably. Okay, there is nothing like we will first place a symbol, then we will assign a different footprint to that. I don't think that there is an option in EasyEDA tool that will give us this kind of liberty. So if that kind of liberty is not present, that means I have to change this battery. I have to place a different battery or a different connector there. So I have to place a different symbol now. Okay, it means I have to place a different symbol. So what I require a 2-pin connector. Okay, 2-pin connector. So I'll go for connectors A, B, and C connectors somewhere here. All right. There are various connectors. This is a connector, banana type connectors. Okay, this is a banana type connector. We have barrier type connectors. I do not require them. I require a pin type connector. There's a circular connector also. If somebody is interested, he can assign a circular connector here. He can place a symbol for that. But I require pin type connectors. Okay, pin type connectors. This one. But the problem with this symbol is that I have many pins. So I will select a suitable one, maybe 2-pin connector. If it is present here, yes, it is present somewhere here. Okay, so I may require this one. So I will go for place this component, place, and I'll place it in my schematic. So once I have completed the placement, I will connect it with my circuit. I'll close. I'll make the circuit as a closed loop. Suppose this is now. So let me draw it in this fashion. I have to connect a wire between this point and all the way to this point. Okay. Now I will now directly create a PCB and then I will see its three-dimensional view. So design, okay, go to design, convert PCB. Please save your file first. Every time I will make a change, it asks me that there's a requirement to save the design first. So go to design, convert to PCB, and then you have all those components again. Okay, remember that I have to uh, arrange all those components of my circuit within this box, which marks actually the size of my PCB. Okay, so then I have a 2-pin connector also. 2-pin connector will be taken here, uh, and a resistor here. Okay, so suppose this is the correct placement of my components on my PCB. Now I have to place the route wires of PCB. I have to place route tracks. Okay, so I'll go to PCB tools, then select track. Track means a route track. Then I will connect all those components from source to destination and make a proper circuit here. Okay. Now, in order to see its three-dimensional view, we have to directly go to 3D. If we go to 3D, you will see that you have now the same PCB. The only thing you have here, you have changed the power supply connector from a button cell type to a 2-pin connector. Okay, to a 2-pin connector. You can literally take any complex circuit. You first have to make it schematic, then update or convert it to PCB, and then directly view its three-dimensional view. So you can normally, I think you can create any complex circuit in this, and then you'll be able to find its three-dimensional view.